So in this video, we want to look at the rational zeros theorem. Let p of x equal a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus and so on plus a sub 1 times x plus a sub 0, where all the coefficients are integers. Consider a rational number denoted by p over q, where p and q are relatively prime, which means they have no common factors besides -1 and 1. If p divided by q is a 0 of p of x, then p is a factor of a sub 0, and q is a factor of a sub n. So this is called the rational zeros theorem, and I just want to kind of explain. Okay, so if p divided by q is a 0 of our polynomial function, then p, the number on top, has to be a factor of the constant term, and q, the number on bottom, has to be a factor of the leading coefficient. So let's look at an example of the rational zeros theorem. So example, given f of x equals 2x cubed plus 7x squared plus 2x minus 8, we want to find the rational zeros and then the other zeros. That is, we want to solve f of x equals 0. And then once we do that, we want to factor f of x into linear factors. Okay? So we can use the rational zeros theorem to see if we have any rational zeros. So remember, the rational zeros theorem means if p over q is going to be a 0 of our polynomial function, then p has to be a factor of the constant, in this case -8, and q has to be a factor of the leading coefficient, which in this case is +2. Okay? So I want to think about the possibilities, or the possible values of p. Okay? And the possible values of p has to be factors of -8. So what can -8 be divided by evenly? Well, it can be divided evenly by either positive or -1, by positive or -2, by positive or -4, or by positive or -8. These are the only integers that -8 can be divided by evenly. So these are the only possible values of p. Now, we also want to look at the possible values of q. So q has to be factors of 2, the leading coefficient. So what are possible factors of 2? Well, plus or minus 1 or plus or minus 2. These are the only possible values, okay, for the value of q. Okay? So if we want to consider the possible rational zeros, then the only possible rational zeros are what we get when we divide these possibilities for p with these possibilities of q. Okay? So in other words, if I take each one of these values divided by each one of these values, that will give me the possibilities. So in other words, if I take plus or minus 1 divided by plus or minus 1. Now the plus or minus just means it can be positive or negative. So positive or -1 divided by positive -1 will be positive or -1. Positive or -2 divided by positive -1 would be positive or -2. Plus or minus 4 divided by plus or minus 1 could be plus or minus 4. Plus or minus 8 divided by plus or minus 1 would be plus or minus 8. Plus or minus 1 divided by plus or minus 2 would be plus or minus 1/2. Plus or minus 2 divided by plus or minus 2 would be plus or minus 1, because 2 divided by 2 is 1, but we already have that listed as a possibility. We don't need to list it a second time. Plus or minus 4 divided by plus or minus 2 would be plus or minus 2, but we already have that. Plus or minus 8 divided by plus or minus 2 would be plus or minus 4, but we already have that. So there are here 1, 2, 3, 4, 5 times 2. There are 10 different possible rational zeros of our polynomial function. There's no other rational numbers that could possibly be zeros of this function. So we want to find any rational zeros that we have, and then any other zeros that we may have as well. Okay? So this is just going to be a trial and error situation. So I'm going to check to see, is positive 1 a 0? Is negative 1 a 0? Is 2 a 0? Is negative 2 a 0? And so on until we find all of the zeros. Okay? So I'm going to use synthetic division for this purpose. If 1 is a 0, then I should be able to use synthetic division, and it should come out with the remainder of 0. If it comes out with the remainder of 0, then 1 is a 0. If it doesn't come out with the remainder of 0, then 1 is not a 0. Okay? So going through synthetic division, I'm going to drop down my 2. 1 times 2 is 2. 7 plus 2 is 9. 1 times 9 is 9. 2 plus 9 is 11. 1 times 11 is 11. Negative 8 plus 11 is 3. That's the remainder. It's not 0. So 1 is not a 0 of our polynomial function. So let's try negative 1. So I'm going to go the same process. Drop down the 2. I'm checking negative 1 here. Negative 1 times 2 is negative 2. 7 plus negative 2 is 5. Negative 1 times 5 is negative 5. 2 plus negative 5 is negative 3. Negative 1 times negative 3 is positive 3. Negative 8 plus positive 3 is negative 5. That's my remainder. It's not 0. So negative 1 is not a 0 of the polynomial function. So that didn't work either. So let's move on to the next. Let's try 2. Okay, try 2. So I'm going to go through the process again. 2, 7, 2, negative 8. Drop down my 2. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. 2 plus 22 is 24. 2 times 24 is 48. And that gives me a remainder of 40. So, nope, 2 is not a 0. So let's try negative 2. Drop down my 2. Negative 2 times 2 is negative 4. 7 plus negative 4 is 3. Negative 2 times 3 is negative 6. 2 plus negative 6 is negative 4. And negative 2 times negative 4 is positive 8. Negative 8 plus 8 is 0. So we do get a remainder of 0 in this case. So yes, negative 2 is a 0. Okay? So out of the possibilities, plus or minus 1, plus or minus 2, plus or minus 4, and so on, so far we found that negative 2 is a 0. Okay? So that means that our function factors into, again, negative 2 is a 0, so that means it factors into x plus 2, and then the other factor will be 2. Now it's going to be x squared because we divided by x plus 2, and so dividing x cubed by x gives us an x squared. It's going to be 2x squared plus 3x minus 4. Okay? So far we know that our polynomial function factors into x plus 2 times 2x squared plus 3x minus 4. Okay? Now, can we factor 2x squared plus 3x minus 4 any further so that we can find the other factors? Okay? Well, if you look at 2x squared plus 3x minus 4, we're not going to be able to factor that. That is a prime polynomial, so we're not going to be able to factor that. So in order to figure out what the other zeros are going to be, we're going to have to use the quadratic formula. Okay? So in other words, I'm going to take 2x squared plus 3x minus 4 and set it equal to 0 and solve so that I can find the other zeros. Okay? And again, these are not going to be rational zeros because this doesn't factor. So let's figure out those other zeros on a new page. So rewriting, I'm trying to solve 2x squared plus 3x minus 4 equals 0. And I can do that by using the quadratic formula. So a equals 2, b equals 3, c equals negative 4. And the quadratic formula, remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, again, I know a, b, and c, so I'm just going to substitute those in. So negative b, so that's negative 3, plus or minus the square root of 3 squared minus 4 times a, which is 2, times c, which is negative 4, all over 2 times a, which is 2. So I have negative 3 plus or minus the square root. Now, underneath that square root, I have 3 squared, which is 9. I have minus 4 times 2, which is minus 8, times negative 4. Minus 8 times negative 4 is going to be plus 32. And 9 plus 32 is 41. So I have 41 underneath the square root and 4 in the denominator. Okay? So that's two things. I have negative 3 plus the square root of 41 over 4, and I have negative 3 minus the square root of 41 over 4. Okay? So we already had found that negative 2 was a 0. It was the only rational 0 of our polynomial function. And now we know that negative 3 plus the square root of 41 over 4 and negative 3 minus the square root of 41 over 4 are also zeros. So here are our 3 zeros. And incidentally, I didn't mention it before, but we do have a cubic function, and so the fact that we have a cubic function means that we should have 3 zeros. And so we have found those 3 zeros. Okay? And so we have those right here. Now in part B, we're supposed to factor our function into linear factors. So let me rewrite our function. Our function was f of x equals 2x cubed plus 7x squared plus 2x minus 8. So what we have found is that this is going to factor into some constant, a sub n, times x plus 2 times x minus our factor negative 3 plus the square root of 41 over 4 times our factor x minus negative 3 minus the square root of 41 over 4. So there will be some constant times our factor x plus 2, which is coming from the 0, negative 2, and then we'll have x minus our 0 here, negative 3 plus the square root of 41 over 4, and then we'll have x minus our factor here, or our 0 here, which is negative 3 minus the square root of 41 over 4. Okay? So f of x is going to factor into some constant times this.